Everyone, on my screen you can see a double skin facade section where we compose the first skin, which is this one. This is the first skin, and this is the second skin. Okay, so before I dive into different, the performance of this, what is the performance, what are the codes and requirements of designing this, let me walk you through the different parts of this system. Okay, this one we call this, okay, this is the transom. Okay, and here we have the shutter, window shutter. Here we have the insulation. Okay, and here we have the backpan. Here at the middle, where you can see the orange strip here, we call it thermal brakes. Okay, and here we call this as an IGU. Why IGU? It's insulated glazing unit. In some uh, part of the world, they are using triple glaze unit. So let's say, in a general term, let's say insulated glazing unit. And here we call it mullion. Mullion is for vertical frames. At the middle, here we have the gratings. Normally it is, sometimes it is made of steel or made of aluminum. As below we have this cladding. Okay, so it's an option if you want to put a cladding or a support or steel brackets. So it's an option in the design. And here we have the louvers. Okay, and we have the glazing. So in glazing, we are using different types of glazing. We are using an IGU, we are using monolithic, we are using laminated glass. And here in between this space, we call it a cavity. Okay. So normally when for the double skin facade, you will allow a worker or a person to walk through on this um, catwalk to clean both sides of the facade. So this person should be able to clean this side of the facade and also this side of the facade. Okay, so now that we are, you know, quite familiar now on the parts of this section, so let me dive on the performance of this detail. So in this detail where I would do some highlights here where we have this, wait, where we have this thermal brakes and also the IGUs. In facade engineering, we are complying on that into EN 13830. That is for curtain wall performance. Okay, so what is inside this EN 13830? What are the recommendations for that, and what are the guidance or the codes or the standard that belongs to EN 130? What I highlighted here, okay, this is the critical line of the facade where we must consider, number one, we have to consider the proper thermal transmittance. Okay, we have to ensure that transmittance. Okay, number two, we have to ensure um, a proper air permeability. And lastly, we have to ensure a better water tightness. So the thermal brakes, okay, these thermal brakes and IGU construction helps the system to achieve the overall U values, okay, because the heat will transfer, to this direction. So these thermal brakes and the IGU should help. This construction should help to improve or achieve the target U value of the system, which should be aligned with this code. I will write the code as REA 90.1 or in accordance with the local codes. Okay. Now, I believe we already discussed the inner layer, the requirement code for the inner layer. What are the parts of the inner layer? Now let's see what belongs to the outer layer of this ventilated skin, composed of what. So basically the outer layer composed of, number one is glazing, okay, number one, and the aluminum louvers. So this is your outer layer of skin, okay. And this outer layer of skin is not as stringent with regards of the requirement that we should comply for the inner skin. Basically, it should comply, I will write a code here, should comply to EN 12114 and EN 13119. This is for, oops, this is for this code is for ventilated facades. Okay, creating a cavity. So the principle is to create a cavity, this cavity that allows, I'll make it red, that allows and control airflows. Okay, these codes, okay, for the ventilated facade. Now, what you can see at the middle bit, what I just explained earlier, this grating, as you can see, will act as a maintenance walk. Okay, this will act as a maintenance catwalk. Okay, and at the same time, it will also serve as a pressure equalization chamber, preventing a heat built up. Okay, because we have a heat built up on this area. On this area, we have a heat built up. Okay, in the cavity, and ensuring that the warm air, we have the warm air here, rises and escapes. Okay, to prevent overheating of this. So let's say you have this plus 50. Okay, may at the middle it could reduce to around plus 40, and then you have plus 23 temperature from inside. So therefore you can uh, improve the performance of the inner facade. You can reduce the condensation, and because of this cavity. So um, through this cavity, like what I said, you can achieve a solar shading. That is number one. Also, you can achieve a solar shading. Let's say you are standing here, and then this will improve the solar shading. which number one, reduce cooling loads inside the building or inside the room. Also, it will improve the acoustic, see, the acoustic buffering. This is per the ISO 10140. Okay, and like what I said, it will enhance thermal stability. It will reduce the facade surface temperature swing. What is surface temperature swing? The abrupt temperature changes from outside to inside. Okay, so as you can see, this system is perfect for high temperature or lower temperature, and then it will also reduce the condensation inside the building. You can also clean the facade, internal facade, very easily through this catwalk. Almost perfect of this system. But even with all of these benefits, double skin facade needs refinements. Okay, now here we go. What is my recommendation to refine this double skin facade? We could integrate what we called is automated cavity dampers. Okay, so what is automated uh, cavity dampers? So it is essentially a movable louver or flap driven by a small actuator. So we have this small actuator here, this small actuator to place in a strategic location of the DSF cavity, usually at the top or at the bottom or in the intermediate bottom or intermediate zone. So what is the purpose of this? So the damper automatically uh, adjusts the ventilation, this ventilation in the facade cavity by responding, that we have this temperature sensor, and we have this is wind speed sensors, and also we have this carbon dioxide. So this will observe the air quality, the air quality. We have this air quality sensor as well, and we also integrate the fire alarm system for this automated cavity damper. So the question is why we need these automated cavity dampers. So without these dampers, this cavity, what we discussed, can be overheated, okay, especially in hot climate. This will lead to large heat load, okay, large heat load here entering to the building. So you have this large heat loads entering the building. There would also a thermal stress on glass and aluminum, and also discomfort near the facade. Imagine that you are standing here, you will feel the heat of created from outside. And also the worst thing is there would be a condensation risk happening at the perimeter of the facade. Also, like what I said, there's a fire alarm system integrated on this automated cavity damper. This cavity damper can switch to a fire close mode. Okay, a fire closed mode, and act as a barrier to prevent smoke or flame to spread. So this will automatically close to avoid any smoke or flame propagated from lower floor to upper floors. So this kind of system, I could say, could control the airflow based on the external temperature, and also it will add the fire barriers and cavity closer. So this is as per this, we could check that into NFA 285 or BS 991, because fire propagation, like what I said earlier, in ventilated cavities this f- is one of the biggest risk. So in this automated cavity damper, this will close this part of the system. And finally, considering a selective coating optimization as well. So here, there would be first layer of glass, and then you have the second layer of glass, and you can put the coating inside this IGU, which balance the daylight, so which will balance the daylight. Number two, solar gain and glare, especially in hot climates. So, in conclusion and in summary, the double skin facade is powerful, okay? But with a smart control, fire safe detailing, and optimized glazing, we can elevate it from a good system to a truly high performance envelope. Okay, that's it. Bye.